So hello everyone, welcome to Hyderabad YouTube channel. So my name is Swagatas. So today I am going to discuss about the introduction to the statistics. So in my upcoming videos, I will be currently actually working on the complete playlist on the statistics which are needed for a data science. So yeah, I'll be in upcoming days. I'll be uploading more and more videos on statistics, which are like I'll be making videos only on those topics of statistics which are relevant to the data science. Okay. So in this video, we are going to discuss about uh, definition of the statistics. Then we are going to discuss about what are the tools we are using in statistics, and then we are going to discuss the type of statistics. Then we will discuss the population and mean, then types of sampling, and then the last one is what are the variables in statistics. Okay, so let's go to the first slide. So if we say the definition of the statistics, let me take the pen. I guess, okay, pen, pen, okay, right. So yeah, if we say the definition of the statistics, so we can say, so it's a, like we can say it's a three steps process. So what are those steps? We can say the first step is collecting the data. Then the next step is analyzing those data, and the last step is retrieving the information from those data. So for example, let's say we want to study. So currently it's a pandemic situation. So let's say we want to study the COVID-19. We want to do some, let's say, statistical analysis of COVID-19 in one of the city, let's say. So in order to do that, so what will be our first step? So our first step will be to collect or to gather some data uh, with respect to that city. Okay, so in so for COVID-19 analysis, we can say, let's say we want to collect some personal information, and let's say age group or medical history of the person who are residing in that city. So after collecting all this information, so what will be our next step? Our next step will be to analyze those information. So in order to analyze the information in statistics, we have different types of tools. So we'll discuss about those tools in our coming videos. So so what are those tools? Mainly, for example, we can say we have histogram. So histogram we are using like to study the distribution of the data. So we'll see what does this distribution mean. We'll see all these things in detail, and we are going to implement all these things in either in Python or in R. Okay. Then another tool is, we can say, box plot. So box plot, which is used to detect the outlier in a data. So these are the different types of analyzing tool we are using in statistics to analyze the data. Okay, so by analyzing those tools, uh, we can retrieve some information from those data. Okay, so all this process are collectively known as statistics. So as per me, according to me, the statistics is like it's a language by which we can have a conversation with the data. Okay, so it's a language, or you can say it's a medium by which one can have the conversation about the data. One can know about what are the hidden information is there in a data. Okay, okay, let's go to our next slide. So here in this slide we'll study what are the different types of tools we have, what are the different types of tools we have for statistical analysis. Okay, so if we say tools, so we can classify all the tools into two categories. Okay, so there are some graphical tools and as well as there are some analytical tools. So graphical tool, for example, we can say box plot, histogram, and analytical tool examples will be mean, median, and then let's say standard deviation, or you can say range. So these are the analytical tools. Okay. Then again, analytical tools also we can differentiate into two categories. Like say measure, to measure central tendency. To measure the central tendency, okay, we are using the mean, median, okay, mode. So these are the analytical tools we can say we are using to measure the central tendency of the data. Again, to uh, measure the dispersion, let's say to measure the dispersion of the data. Dispersion means just the distribution of the data. To measure the distribution of the data, the tools we are using like range or standard deviation or variation. So these are the two analytical tools we are using to measure the standard deviation, to measure the dispersion of a data. And in terms of graphical tool, we have box plot, histogram, we have scatter plot. So don't worry about all these names. I'll be uploading more and more videos on all of these tools, and we are going to see how these can be implemented in SAS, in R, and as well as in Python. So I'll try to implement these tools in all of these three languages. So I'll also make videos and I'll upload those videos on YouTube as well, on my PyTuber channel. Okay. So next, let's go to the next slide. So if we say what are the types of statistics we have, so we can say we can uh, we can segregate the statistics types into two categories. So one is like descriptive statistics, another one is inferential statistics. So descriptive statistics, from the name itself we can see it's describing the complete data. So complete data means, so there are two terms we mainly use in the statistics. Throughout the statistics we use these two terms. One is population, another one is sample. Okay, so in my next slide I'll show you, you'll see like what is the population and what are the samples. So so if you see the definition of the descriptive statistics, so descriptive statistics means it will describe the data of all the population. So for example, let's say mm, there are 100 students in a class. Okay, and the teacher wants to analyze what is the average or mean marks of that class. In order to do that, in order to analyze this average or let's say mean of the mean mark, so what the data teacher needs is the data of the complete class, right? The teacher needs the data of the complete class. So that is the example of descriptive statistics. And the example of inferential statistics is let's say we have population and we have some sample. Sample is nothing but a subset of the population, we can say. Let's say there are 100 people who are staying in a city. And same thing as our last example, let's say we want to analyze uh, how this city is affected because of the COVID-19. Okay, so there are, let's say, 100 people who are staying in this city, and we want to analyze how this city has been affected because of the COVID-19. So what we can do, one can do like instead of taking the data for all the 100 people, they can take the sample data. The sample means we can take the data of only 20 people, or let's say 10 people, and from them, from those data, we can like do an estimation about the complete population of that city, about the all 100 people who are staying in that city. So here, those 100 people is known as the population, and the 20 or 10, the sample which you did, that is the sample. Okay, so in this figure also you can see from a population we are taking the sample, we are selecting a sample, and uh, by estimating or by analyzing this sample, we are estimating the parameter of the population. So that's why it is called inferential. Like from the sample data, one can inferencing about the data of the population or the parameter of the population. So sample data can be used to infer about the data or the parameter of a population. So that is known as that inferential statistics. So let's go to our next slide. So here you can see, as I was telling, let's say this many people are there. Okay, let me take the pen. Okay, so let's say that this many people are there in a city, and where we want to analyze the COVID situation in this city. So instead of taking or instead of collecting all the data, what we can do, we can collect only this many data. Let's say only the data of how many people, 1, 2, 3, 4, 5, 6, or 6 people data you can collect. And these 6 people data will be used to estimate the parameter of the population of the uh, people who are staying in the city. Okay. So let's go to the next slide. So here we are discussing about what are the variables are there in the statistics. So again, here we can also broadly classify the variables into two types. Okay, one is qualitative, another one is quantitative. So quantitative is showing some magnitude of the data, and here qualitative means it's like showing the quality of the data. You can say quality of the data. Again, you'll be able to understand all these things when I take one example and I explain you. So you'll be able to understand all these things clearly. So qualitative uh, data, it can be again categorized into nominal and ordinal data. Okay. So nominal data, we can say, let's example, uh, we want to study about the COVID-19 situation in a city separately for male and for female. Okay, so see, we cannot give a rank to these two types of data. Can I give assign a rank, let's say rank 1 to male and rank 2 to female? Then let's say there is another category which are the, you will give the rank 3. So this is not possible, right? So this type of data is known as nominal data, and where data can be ordered, where data can be ordered, okay, or we can give a rank to a data. Those data are known as ordinal data. Okay, let's say about some Swiggy rating. Let's say you got one parcel, you got your delivery from Swiggy or let's say Amazon, and after getting the delivery, you are asked to give a rating about the like delivery service. Okay, so rating will be 0 to 5, right? So on this scale you need to give a rating. So this is known as ordinal data. Means 0 means let's say poor, and 5 means outstanding. Okay, so this is something known as ordinal data. Okay, similarly, the quantitative data, it can be categorized into two categories. One is discrete, another one is continuous. So discrete data, for example, I want to study how many cities are there in a state. Okay, so that number could be 5, 10, or 15, something like that. Okay, so this is discrete data. I cannot say there is 5.5 number of cities in a cities number of cities in a state. So this is not valid, right? So so this type of data is known as discrete data. And the continuous data, let's say I want to measure height or weight of a person. Okay, so height could be like 5.11 or 5.10 or 5.12. So this is like, these are continuous data. Okay, so I hope you are able to understand the difference between the qualitative and quantitative data and discrete, continuous, nominal, and ordinal data. I hope uh, so you are able to understand all this from this slide. Okay, so let's go to the next slide. Here we are discussing, so actually this is you don't need it. This is I can say a bonus slide. You don't need it for data science purposes. You don't need so much theory, but yeah, it's good to know. So if we say what are the types of sampling we have, we can categorize the sampling into two types. One is random sampling, another one is non-random sampling. So random sampling is also known as probability sampling, and non-random sampling is also known as non-probability sampling. So random sampling means, let's say in a population, there are 5 units. Okay, okay. Let's go to the slide. Okay, so we are discussing about the types of sampling. Okay, one is random sampling, another one is uh, non-random or non-probability sampling. So what I was telling, let's say 5 people are there in a city, for example, and when you are selecting the sample, each one of them, we in that statistics term, we call it unit. Okay, so unit of observation, uh, so collectively known as population. Okay, so each one of them or each unit have a like we can say have, have same probability of getting selected. Okay, when we are like collecting the sample from this population, each unit have the same probability of getting selected. Then this is known as random sampling. Similarly here, if each unit, not every unit, if said not every unit has the same probability. If not every unit has the same probability of getting selected, when we are taking a sample, when we are deriving a sample from a population, let's say each one of them is not having the same probability of getting selected, So in that case, we are calling it as non-random sampling. And random sampling again is classified into four types. One is simple, stratified, systematic, and clustered. Similarly, the non-random sampling is again classified into four types: convenience, judgment, and snowball sampling. Okay, so so this is all about today's videos. So I think you all are able to get an idea about what is statistics and like many different terms associated with the statistics. So in my upcoming videos, I'll be uploading I'll be implementing all these in Python or SAS. So I'll upload all those videos also. I'm planning to make one statistics playlist for data scientists. Okay, thank you.